All right, today we are working through solving equations. Hopefully you've enjoyed the previous couple of videos. Today we're looking at equations. We're solving for variables. We're going to keep it pretty straightforward and simple for now. When we start diving into more complex functions, we'll start increasing the difficulty a little bit. But I want to quickly remind you guys, we have learned PEMDAS for years, right? Please excuse my dear Aunt Sally, the order of operations, that thing that we know to use to simplify and evaluate expressions. And we do kind of use it with equations because remember, like I said on the first day, equations are just two expressions, right? Separated by an equal sign. So within each of those individual pieces, we're going to use this PEMDAS, this order of operations, to simplify individual things, and we'll see that in some examples here in a minute. But one thing you probably haven't been told, but one thing that I like to always tell my students, is that when you're solving equations, after you've done the simplification, after you've done that initial step of using order of operations to get things simplified on each side of the equal sign, in order to move things across the equal sign, we're actually going to go the opposite order. We're going to start with addition, subtraction, and then we're going to go to division, multiplication, and then we're going to look at these last two exponents in parentheses. And that's pretty much reliably how it's always going to play. There are some exceptions. It's not a perfect rule. It doesn't work quite as consistently as PEMDAS does, but it is a valid rule to go by when you're solving equations. So here, this situation, this 4x plus 7 equals 35, is actually simplified already. We don't have to bother with order of operations the first go around because I can't do anything to add 4x and 7. Those are not like terms, and then 35 is the only term on the right side. Those don't simplify. But that means we need to start into our solution. And we're going to start with addition, subtraction. And the only situation where we have addition is here, the plus 7. Okay, and as with every operation that we do in solving an equation, the way we take care of this is we're going to do the opposite thing, whatever the opposite is. So the opposite of addition, that's going to be subtraction. And what I do to the left side, I have to now also do to the right. So that is going to cancel. We get rid of those values. We copy down the 4x. And we do the subtraction here, 35 minus 7. And that's going to give us 28. So 28 is that right side after that step. There are no other forms of addition or subtraction, so we're going to look at this next. This next thing is 4 multiplied by an x. So once again, we're going to do the opposite process, whatever the opposite process is of multiplication, and then in this case that's division. So we're going to divide that by 4, and then we're also going to divide the right side by 4. 28 divided by 4 is a nice clean 7. So you see how we started here with subtraction addition and we worked our way backwards until we got our x. If there were an exponent, we would then have to do something to get rid of the exponent. If there were parentheses, we would then have to do something with the parentheses. And I'll kind of show you edge cases where those are useful. But we'll look at that probably in part 3. So let's look at another quick example here. This time we've got 2x minus 3 plus 4x equals 21. And the right side, just one term, doesn't have to be simplified, but that left side does need to be simplified here because I've got the 2x and the 4x, and those two terms can be combined. So we actually need to use PEMDAS first. We need to simplify that left expression, and then we use SADMAP. So we take the 2x and the 4x, we're going to add those two together. They're going to be 6x minus 3 equals 21. Then from there, left side is now simplified. I can't do anything else with those two values on that left side. So we're going to work backwards again. Addition, subtraction. And again, the only situation where we have either of those is this right here, this -3. Do the opposite thing. We do +3 instead of subtract 3. We get 6x equals 24. And then we need to divide, right? Divide. We need to divide by 6 to simplify and solve for x. Let me circle that better. That's better. Okay. What else do I have here? Okay. Oh yeah, this is good. This is good. Let's look at this one. So we've got 4x minus 4 equals 20 minus 4x. Let me switch to red here, just because I like switching up colors. It's a thing I like to do. And this time, neither side has to be simplified, but we've got multiple things we're going to have to move around, right? We're going to have to take a step to add 4 to both sides. Okay. Notice that I keep the 4 lined up with the -4. That's the thing I'm trying to counteract, right? And I keep it lined up with the 20 because that's the term on the other side that it is similar to. I wouldn't line it up with the -4x because 4x has a variable attached. It's not a like term with the 4 that I'm moving across. So we don't line it up with that. We line it up with what is similar to. So 20 plus 4 gives us a nice 24 minus 4x. And this time, before we're able to just go straight to x, we have one more step we've got to do, right? We need to move this guy over now. We need to add 4x. So we're not done with that addition subtraction just because we did it one time. We've got to make sure that every side, every term has been added or subtracted in both directions to get the like terms together and to get the x's in particular on the same side. That's very important. So 4x plus 4x gives us an 8x, and then we have 24 on the right side. And now that we've done all the addition subtraction, only thing we have left to do is to divide. And that's going to give us x equals 3. X equals 3. Very nice. All right. I'm going to pause things here, and we'll come back after TIA. Okay, so I wanted to take another look at this equation that we solved at the end of part 1, because I wanted to bring a couple of interesting things up. This is the last two problems I'm working through are edge cases, things that might be a little more complex or a little bit more difficult, but they're worth talking about because they're going to lead into other things we're going to do later. Honestly, not that much farther down the road. So first thing is with this guy, we did solve it following our order of operations and then also the SAD map. We did that very, very well, but there are alternative pathways to solving this equation. There are other strategies we could use to tackle this, and it's worth looking at them. So when we look at this here, there should be a number that pops out to you quite a bit as we're looking at this equation. And that number, very intentionally, is 4. I decided that I wanted to put as many 4s in here as possible because it would give us some opportunities to do some cool things. So if I look at this expression here, this left side of the equation, I've got 4x minus 4. I can take a 4 out of this term. I can say 4, I want that divided out, okay? And I can also take a 4 out of this term, and I can factor that. That's what we're calling this. We're taking a value, we're dividing it out of both terms in an expression, or we're moving it outside. We're using parentheses to indicate that we've done this. And all that's left with each of these things after we divide a 4 out is a 1, right? There's a 1, an invisible 1 in front of the x here. That's hidden right there. And then there's the very obvious negative 1 that we've got left over here. And then on the right side, we can actually do the exact same factor, right? 20 and negative 4 are both also divisible by 4, so we can divide a 4 out. And then we can write down whatever is left. So 5 minus x, right? We've got that set up. So I'm kind of breaking the rule that I started the lesson with, right? I said, if we've got an equation that is simplified as far down as it can go, the best strategy is to follow that SAD map. And that's still mostly true, but as you can see, using this, there's some things that we'll be able to do to kind of break that order. Instead of going addition, subtraction, and then multiplication, division, we can set this up so that it's in a situation where there's a number multiplied by another number inside parentheses in both sides of the equation. And we can do division to cancel out that number, so I can divide here, divide 4, and divide 4. And in this situation, it's going to very cleanly, actually, cancel out the 4's on both sides. We have x minus 1 equals 5 minus x remaining, right? And this is kind of nice because now the numbers are much smaller. They're easier to play with. This is a strategy you can employ when the numbers you're working with in the equation are larger than you're comfortable with. You can check your calculator, you can punch some numbers in, you can see, is this going to simplify the process? Can I make my numbers smaller so that they're easier to add and subtract? And then from there, we follow the same rule we've already learned. We add 1, right? We add 1, and then we have x equals 6 minus x, and then we add an x to both sides, and we got 2x equals 6, and then, of course, we'll divide by 2. And both of these got us the same solution, right? The one strategy was probably faster, the first strategy we started with, and it was probably easier, you probably understood it better, but the second strategy is useful, like I said, for specific edge cases where numbers are too large or things like that. And it also kind of helps you know what to do. Okay, what do I do if I've got something like this. If I've got a number outside parentheses like this, what's the best strategy for getting rid of that number? Well, as we saw, divide both sides by that number. Okay, and that can be a good way to cancel it out, and then drop those parentheses and move on from there. Okay, so 2 helpful tips that came out of this there. We can reduce numbers by division, and we can simplify or solve equations with parentheses by dividing the number outside the parentheses. So keep that in mind, it'll be helpful. The only other edge case I wanted to talk about today, and I'm not expecting you to run into very many of these in your homework today, but I do want to cover them because I love fractions, and I think we need to talk about them. I think we need to be comfortable with them. So we've got 2/3 x plus 4 equals negative 2/3 x minus 8. And again, as before, we're just going to walk through the process of checking to see if either side can be simplified, and in this case they can't, right? We've got 2 unique terms, the 2/3 x and the negative 2/3 x don't add together yet because they're across the equal sign. We're not allowed to combine them until we've moved them. And the 4 and the negative 8, they don't combine because we have to move them to each other in order to get them to combine. So we can't use PEMDAS, but we now are going to instead use SADMAP. We're going to work our way backwards doing opposite processes. And we'll start with this 4. This 4 needs to be moved across the equal sign. That lets that cancel. We have 2/3 x equals negative 2/3 x minus 12, right? And that puts the constants together. Now let's move the variables together. We need to do something super similar. We're going to add 2/3 x, and we're going to add 2/3 x. Cancel that out. And 2/3 plus 2/3 is 4/3, not 4/6, right? Remember that when we're adding fractions, we add the top number, keep that bottom number the same. Make sure that you've got that down. And that's going to be equal to negative 12. Now, what do we do here? Well, it's actually pretty simple, okay? The thing that's going on between 4/3 and x is multiplication. So technically, what we're going to be doing is a fancy form of division. Normally, you would say, divide this thing by the number that's there, right? Divide by 4/3. But dividing a negative 12 by 4/3 is kind of complicated. What I do to the left side, I got to do to the right, and I don't know right off the top how to divide negative 12 by 4/3. So, the trick, the fancy trick for you guys today, is that when we have a fraction multiplied by a variable like this, the actual best strat is to take that fraction and flip it on its head. Right? Flip it on its head. Okay? And the nice thing about that is that when we look diagonally, if there's a 3 on top and a 3 on bottom, those cancel. A 4 on top and a 4 on bottom, those cancel. We're left with just x on the left. And over here, once again, I've got a 4 on the bottom. What's 12 divided by 4? Well, it's 3. So we've got a negative 3 multiplied by a positive 3. And the bottom number is just 1, right? 4 cancels out to be a 1. 1 times 1 is 1, so we're left with just a whole number of negative 9. And that's our solution. That's it for today. Good luck on your homework, and good luck on your quiz tomorrow as well.